Alright, let's start question 2 on the homework from the A side. So, again, we need to start with what's given, and our end goal is to prove that the two triangles are congruent. So, we need to end with one of these cards, AAS, ASA, SAS, or SSS, because we want one of these to be our output. It's our goal. So let's start with what's given. We know that XM bisects, so this line right here, XM bisects or cuts in half this angle right here, YXM. So what that means is this angle is congruent to this angle. Now, let's write this out. XM, and I'll write is the bisector of angle YXZ. Now, which of these cards down here shows us that a line segment is the bisector of an angle? So, just looking at the inputs and outputs, now with the cards we're given in class, you could flip them so that the order changes. This would end up over here, and this would end up over there. But regardless, we know that an input would be the same as an output. Okay, so this one says blank blank is the bisector of blank blank. You might think for a moment that we would use this, right? But this is segment bisector. That's not what we're looking for. We're looking for this one right here. Blank blank, XM, is the bisector of XYZ. So we'll pull this card. That's the input. XM is the bisector of YXZ. Therefore, we know two angles are congruent. Which two angles? Well, we just talked about it right here. We know that YXM is congruent to angle ZXM. Great. Now let's get to the other provided piece of information. XY is congruent to XZ. So XY is congruent to XZ. So let's come over here and show what that means. We can mark it like this. We know those two are congruent. So two side lengths are congruent. Good. That's one of the inputs for our ending cards, right? So there's nothing else we need to do with that. It'll fulfill one of the inputs on our last card. So we can leave that as is. Now, that's just the provided information written in mathematical statements. We need to now look at P, picture. What's given in the picture? So looking at the picture, I noticed a lot of students in class would say, oh, this is perpendicular. These two angles are congruent. Now, we don't actually have a property or a theorem that states that we can use, because although we know that these side lengths are congruent and these angles are congruent, we feel that we can write, oh yes, well, then this is 90 degrees and this is 90 degrees. But we can't use that as an assumption. Instead, we can look at points X and M and notice that it's a shared side of both triangles. So actually, XM is congruent by XM, and again, that's by the reflexive property. So let's take the reflexive property. simplify the picture, we know by reflexive property that xm is congruent to xm. Awesome, we have 3 inputs for an ending card. Angles congruent, sides congruent, and sides congruent. So, which of these is going to work? Say it. That's right, SAS. Side, angle, side. So we'll copy, paste. This is our end goal, and we have sufficient means to go with it. And if you actually look at the order, you can tell we have a side, just like over here, and then an angle for both of these, and then 2 sides. So side, angle, side. Again, this was our end goal, and we've achieved it. XYM is congruent to XZM. So let's write it. XYM, triangle XYM is congruent to triangle XZM. And we're good.